Hello and welcome to another episode of Interactive Biology TV, where we're making biology fun. My name is Leslie Samuel, and in this episode, episode 43, I'm going to go into the details of muscle contraction. This is going to be the last video in the muscle contraction series, so enjoy. Let's get right into it. Now, you can always go back to episode 42 to refresh your memory, but we said that the functional unit of contraction is called the sarcomere, and that is what we're looking at right now. This unit is one sarcomere. And we said that we had a thick filament that was called myosin, and we have a thin filament that is called actin. And we said that when muscle contraction happens, the motor neuron releases neurotransmitter that stimulates calcium release. And when that happens, the fibers slide against each other, just like this. So as the muscle fibers become shorter, that is the muscle contracting. And you can clearly see that in this animation. Now, the reason we said that this can happen is because on the myosin filaments, we have these heads, and those heads extend and bind to the actin. And when they bind, they kind of flex. So it moves in this direction, and that pulls the actin, shortening the sarcomere. So what we're going to do today is we're going to look at the details of what is happening there. So we're going to look at the 6 steps in muscle contraction. And this is another image that's showing something similar to what we've looked at. We have the myosin heads. Let me do that in a different color so that you can make sure to see it, because we have a lot of red there. So we have the myosin heads that are binding to the actin filaments. Now here we're going to be looking at that in more detail. So we have the actin. Yes, it's a different spelling because it's from a different language. But on the actin filaments, there are 2 things that are very important. We have tropomyosin, as you see here. So that's this long strand here. And on top of the tropomyosin, we have troponin. And this is a complex that we find all along the actin filaments. Now, here's the situation. Because this is here, the myosin heads want to bind to the actin. There's some binding sites on the actin. So let's say this is a binding site right here. But what's the problem? The tropomyosin is covering that binding site, so the myosin heads cannot bind. Okay, so we have these myosin head binding sites all along the actin. Myosin heads want to bind. We have all these myosin heads ready to do their business, but they cannot because it's blocked by the tropomyosin. All right, so let's go now and look at the 6 steps of muscle contraction. Step number 1, calcium is released from the terminal cisternae. Remember we said that the terminal cisternae is a part of the sarcoplasmic reticulum, and that is where calcium is stored. So calcium is released. You can see here we have this little binding site for the calcium. So the calcium now comes and binds to the troponin. So here we have calcium in binding to the troponin. And then what that does is it causes a conformational change. To put it more simply, we're just moving the tropomyosin troponin complex. So that moves, and when that moves, it exposes the binding sites on the actin. That's step number 1. So step number 1, we had calcium in the terminal cisternae. That is released when there's a stimulus. The calcium ions bind to the troponin, causing a conformational change in the troponin tropomyosin complex. In other words, it's moving out of the way. And then the next step can happen, and that step is the myosin heads can bind to the binding sites on the actin. So this is one binding site, and for simplification, we're just showing one myosin head. But as you know, we have many myosin heads all along this actin. Now, in order for that to happen, we said that there's normally ATP that's on the myosin heads, and you saw that in the previous figure, but that ATP has to be hydrolyzed to become ADP and an inorganic phosphate. So we have ADP and the phosphate. All right, so we have the myosin head that has bound to the binding site on the actin. That was step number 2. Step number 3, this ADP and inorganic phosphate is released from the myosin head. I'm not showing that in the figure, but just imagine that being released. When that is released, it causes the power stroke. In other words, it causes this guy here to flex. And when it flexes, it moves in this direction, and that causes the actin to slide across the myosin. Okay, so calcium is released. Step number 1, binds to the troponin, causes this change in the troponin-tropomyosin complex so that it gets out of the way. ATP being hydrolyzed into ADP and inorganic phosphate is the state that this needs to be in for the myosin head to bind. When those are released, the myosin head flexes and we get the power stroke. That's step number 3. Let's go to step number 4. Step number 4 is another one that I'm not showing, but we have ATP. So this is an ATP molecule that comes in and binds to the myosin head. When that binds to the myosin head then detaches from the actin, so we no longer have that connection. That's step number 4. Step number 5, ATP is hydrolyzed, which re-energizes the myosin head. So once we have ATP being hydrolyzed, like it is here, that re-energizes the myosin head, and it's ready to go again. One more step, step number 6. This calcium here needs to be gone. So we have the terminal cisternae, and it's not shown here, so I'm just going to draw it with my great artistic skills. And we have calcium pumps in the terminal cisternae, and what that does is it basically pumps that calcium back in. So we have calcium being pumped back in. That is going to cause the troponin-tropomyosin complex to go back where it was, and it's going to be blocking. I should have done that in green to keep the consistency. I still can. Why not? Okay, so we have our troponin-tropomyosin complex that is blocking, once again, the binding site for the myosin head. All right, so let's recap on that really quick. Step number 1, calcium is released, binds to the troponin. When it binds, it causes a conformational change, or a shift, whichever one you want to call it. It causes that shift, exposing the binding sites on the actin. Step number 2, myosin head binds to the actin. Remember that the ATP has to be hydrolyzed into ADP and inorganic phosphate in order for that to take place. It has to be re-energized. It gets that from that hydrolysis process. Step number 3, ADP and inorganic phosphate released. That causes power stroke. So it causes this guy to flex. Then ATP comes in, binds to the myosin head, causes the myosin head to be released from the actin. The myosin head gets re-energized when the ATP is hydrolyzed back into ADP and inorganic phosphate. Calcium ions are pumped back into the terminal cisternae, and this process can happen again. Well, that's pretty much it. That is muscle contraction. If you have any questions, go ahead and leave them in the comments. That's all for this video, and I'll see you in the next one.